let's look and see what happens here when we change the dimensions of a particular figure proportionally. Okay, so it asks us to describe the effect of each change on the perimeter and the circumference and the area of the given figures. Okay, so obviously to talk about circumference, it has to be a circle. Okay, if it's a polygon of sorts, we have to call this perimeter. All right, so this one says we want to know the effects of the base and the height of a rectangle with a base of 4 and a height of 5 feet, and both of those, the base and the height are doubled. Okay, or in other words, multiplied by 2. So again. The base and the height, we want to know the base is 4 feet, height is 5 feet, and then both of these things are actually doubled, right? So let's just look at our original figure. Okay, maybe I can just draw this thing real quick. It says a base of 4 and a height of 5. I'm going to try to draw a picture to the best of my abilities here. Okay, the base is 4 feet, and the height is 5 feet. Okay. Again, since it is a rectangle, we could say that this is also 4 feet, and the sides opposite here are 5 feet. Okay, and so it's pretty easy to say that the area of this figure is going to be base times height. So we'll say area equals base times height. So the area is going to be equal to 4 times 5, and the area is going to be equal to 20 square feet. Okay. Now let's go ahead and take a look at the perimeter here. Okay. Whoops. Okay, let's take a look at the perimeter. All right. So the perimeter of this particular figure is going to be equal to 2 times the base plus 2 times the height. So the perimeter will be equal to 2 times 4 plus 2 times 5. Which is, using the order of operations, will give me 8 plus 10. So we find that the perimeter of this original figure is going to be 18 feet. Okay, great. All right, so that's definitely a good start as to like what we're working with. Now let's see kind of what happens maybe when we talk about like this new figure. Okay, so this new figure. Okay, you said that both the base and the height are basically going to be doubled, right? So I'll try to double this. I don't know if it's going to be perfect, but again, it's going to be a rectangle that's about like this. So if you double the height, I guess that would be 10 feet here. So I'll label 10 feet on both sides. And then if you double the base, I guess this would be 8 feet and 8 feet. Okay, so the area would still be base times height. And the area is going to be equal to, I guess, 8 times 10. So that would give us an area of 80 square feet. Okay, and now we want to take a look at the perimeter. All right, so the perimeter here, it's just going to be the same formula. The perimeter is going to be 2 times the base plus 2 times the height. So the perimeter is going to be equal to 2 times 8 plus 2 times 10. Right, and this would basically end up giving us a perimeter of 36 feet. Okay, and so we've basically now just calculated both of these things, right? And we want to know now, kind of have some sort of summary, right? So let's maybe look at the perimeter first. Okay, so let's say like the perimeter. It looks like when we look at 18 feet and 30 feet, if you multiply the perimeter by 2. You end up getting the perimeter of the new figure, right? So let's say the perimeter, or maybe I'll start my sentence differently. I'm going to say, I'll say when the dimensions were doubled, okay, I'm going to say the perimeter was multiplied by 2, or also doubled, okay, because 18 times 2 is going to be equal to 36, okay? The area in this case is a little bit different. The area was multiplied by, it's actually going to be 2 squared, which is the same thing as 4. right? Because the original area was 20. Oh, sorry about this. I gotta get rid of this thing. Okay. So again, the area was multiplied by 2 squared, which is 4, right? Because the original area here was 20, right? And 20 times 2 squared is going to be equal to 20 times 4, which is actually going to be equal to 80, right? Okay, so it's important to understand that the perimeter was just doubled, right? But the area was actually multiplied by 2 squared, which is 4, right? So the effects were a little bit different, okay? Let's maybe look at a different example here and see how this one goes, okay? So this one says, describe the effects of each change on the perimeter or circumference and the area of the given figures, okay? And so this one, it gives us the radius of J, and it's telling us it's multiplied by 1/5. Okay, so this time it's a circle, right? So we're going to look at the circumference and the area, okay? So let's just say the original figure. All right, so we will call this our original figure. Okay, so our original figure, let's just say their circumference, we'll start with the circumference. We'll say the circumference equals 2 times pi times radius, right? And so that would mean that the circumference is going to be equal to 2 times pi times our radius here is 10 centimeters. And so if we simplify it, we'll get that the circumference is equal to 2, or actually 2 times 10, we'll just write 20 pi centimeters, okay? And so we'll start there, okay? And let's actually go ahead and do the area here as well, okay? So let's say that the area is going to be equal to pi times radius squared. So our area is going to be equal to pi times 10 squared. And our area is going to be equal to 100 pi square centimeters. Okay, so we'll start there. We definitely have a good start. Let's see what happens kind of with our new figure, right? So our new figure, okay, our new figure, remember our radius is multiplied by 1/5. Okay, so basically we're saying 10 times 1/5 equals 10 divided by 5, which is 2. Right, so our new radius here is 2. Okay, so let's see what our circumference will be now. So our circumference is going to still be equal to 2 times pi times radius. Remember, our new radius is 2, so our circumference will be 2 times pi times 2. Okay, and our circumference is basically going to be equal to 4 pi centimeters. Okay, and let's see what now happens to our area. Okay, so for our area, okay, our area is still going to be equal to pi times radius squared. So our area will be equal to pi times 2 squared. And we'll see that our area is going to be equal to 4 pi square centimeters. Okay, so let's kind of, look at this given the, I guess the scale of how our radius shrunk this time, and see if we can sort of draw some conclusions, right? So our original circumference here was 20, okay, and our 20 pi centimeters, and our new circumference was 4 pi centimeters. So let's just see how that changed, okay? And so what I'm going to say is, I'll say when the radius was multiplied by 1/5, we'll say this, the perimeter was also multiplied, perimeter, I'm using the wrong word here, sorry. Let me get out of the quadrilaterals / polygons mode, and let's go circumference. Was also multiplied by 1/5. Okay, because we'll say because 4 pi centimeters over 20 pi centimeters. Okay, if we reduce this, pi over pi, centimeters over centimeters, if we divide both the top and the bottom by 4 here, okay, we would see that that this is actually going to be 1/5. Okay, and let's talk really quickly about what actually happened to our area. Okay, so we'll say the area was multiplied by. Okay, let's see what happened here. So let's take the new area, which is 4 pi centimeters squared, and let's divide that by the old, which was 100 pi centimeters squared, and let's reduce this. Okay, so again, centimeters squared over centimeters squared, pi over pi. If I take 4 divided by 100, if I just reduce this, if I divide both the top and the bottom by 4, I'll end up getting 1/25, which is actually the same as 1/5 squared. Okay, and so again, it's important to understand that when we actually change these dimensions proportionally, it's going to affect the perimeter and the area differently. Okay, and so the next couple slides actually summarizes this really well. Let's take a quick look. Okay, so this says when the dimensions of a figure are changed proportionally, the figure will be similar to the original figure. But look what happens here. Okay, so this says the effects of changing dimensions proportionally. So if the dimensions are multiplied by a, okay, the perimeter changes by a factor of a as well. But the area is going to change by a factor of a squared. So for example, if we look at the last example, our radius was multiplied by 1/5. Okay, therefore our circumference was also multiplied by 1/5, but our area was multiplied by 1/5 squared, which is 1/25. Okay, so again, it's going to take a little bit of practice with these particular examples. Okay, so make sure that you take a look at your homework and maybe ask some good questions in class here.